Next on the agenda is going back to what John was talking about at some length before, talking about the Caloosahatchee and the water release. And we are fortunate to have with us this morning James Evans, who's been a long-time scientist working for the city of Sanibel. Thank you for coming all the way down here today, James. Appreciate it.
Thanks, and I want to thank Don for inviting me to speak to you today, and I'm not sure that I can do a better job than Councilman McLean did in explaining so clearly and concisely this issue. I think he did a really good job of kind of laying it out, especially at the 30,000 foot level. I'm going to get into a little more of the details, but again, my name is James Evans. I'm the Director of Natural Resources for the City of Sanibel. I've been with the City of Sanibel going on 19 years in January, worked on a lot of different issues. My focus areas are really on estuarine ecology, freshwater ecology, marine biology, things like that. So I've worked with a team of scientists from the Sanibel Captiva Conservation Foundation, as well as John Cassani, the Caloosa River Keeper, as a number of other folks on various panels, boards, committees working on these issues. So today I really want to kind of talk about the Caloosahatchee minimum flow and levels issues that we're dealing with today. And as the councilman indicated, the city of Sanibel, along with the other cities of Lee County, 6 cities, of course, along with the Captiva Erosion Prevention District, which is a special district on Captiva, as well as the Captiva Community Panel, are all joined on a petition. We're joint petitioners challenging what's called the Caloosahatchee Minimum Flow and Level Rule Update. And so what I'm going to do is I'm going to go through a little bit of the history of where, how we got to the situation we're in today, how we're connected to Lake Okeechobee and the greater Everglades ecosystem. And then I'm going to talk specifically about the minimum flow and level rule so you all know what it is and what it isn't. So as you know, the Caloosahatchee, Sanibel's located right here at the mouth of the Caloosahatchee. Estero is located somewhere down here. And you'll notice that up here in this image here, this shows the area of the South Florida Water Management District. It includes 16 counties. It includes the watershed that extends all the way south of Orlando through Lake Okeechobee and into Lee County here. And because of the connection between the Caloosahatchee River and the Lake Okeechobee, as well as the connections made to the Kissimmee, our watershed really contains that entire area, but the Caloosahatchee watershed alone is about 865,000 acres of land. So that's a tremendously large watershed in and of itself without the connections that were made to Lake Okeechobee and of course to the Kissimmee. And so we go back in time, prior to the 1880s, the Caloosahatchee historically was not connected to Lake Okeechobee. It wasn't until an industrialist from Philadelphia that came down in Florida, bought about 4 million acres of land. His name was Hamilton Diston, and he dredged a connection from the Caloosahatchee to Lake Okeechobee with hopes that he could drain the lands around Lake Okeechobee and in the Caloosahatchee watershed and north of Lake Okeechobee in the Kissimmee watershed for development, for agricultural development and future development throughout Florida. And unfortunately, it worked well. And that was, of course, transitioned later to the Army Corps of Engineers. And there was a congressional authorization that allowed the Army Corps of Engineers to carry that plan forward. And it was turned into what's called the Central and South Florida Project. And that allowed the Army Corps of Engineers to dredge, ditch, and drain and channelize the entire ecosystem from south of Orlando into the Lake Okeechobee, east to the St. Lucie and west to the Caloosahatchee, and of course south into the Everglades ecosystem. My focus today is really on the Caloosahatchee, but we can come back another day if we want to talk about Everglades restoration. But you can see here, this image shows this blue line here is the historic meandering channel of the Caloosahatchee River prior to the dredging that occurred in the 1880s when Hamilton Diston made those first connections. This image is taken from around 1920, but you can see the straightened, what we call now the C43 canal. They don't even refer to the Caloosahatchee as the Caloosahatchee. It's really, when you're working with the agencies, it's referred to as the C43 canal. And of course, when you straighten a system like that, you change the natural benefits that a meandering river and the oxbows that slow down the flow of that river would produce when it comes to water quality. And in the Caloosahatchee, we have two major issues. And we like to refer to this as the Caloosahatchee conundrum and the Goldilocks principle. We either get too much water when we don't need it during the rainy season, or we don't get enough water when we actually do need it during the dry season. And so I'm going to be focusing on the too little water today. But as you know, over the past several years, including what happened this year, beginning in May, when the water levels within Lake Okeechobee get really high, the Army Corps of Engineers discharges that water to tide, east and west. And the Caloosahatchee River, of course, gets the lion's share of that water. And with that water comes a lot of nutrients, such as nitrogen and phosphorus. And that nitrogen and phosphorus can drive algae blooms like we see here in 2006. This is algae that's piled up on Sanibel in 2006, red drift algae. This is also some algae that blanketed the Ding Darling National Wildlife Refuge, which sees almost 1 million visitors per year. And obviously those types of things have a tremendous impact on our local economy as well as the ecology of our coastal waters. Again, I'm going to be focusing on the low flow issues, but not only do we see these nutrient issues and algae blooms that occur during the high flow issues like this year, we also see them when we don't get enough water. This is an image. This is the east side of the Franklin Lock and Dam. This is the Franklin Lock. We also refer to it as the S79 structure. This is the estuary side. The San Carlos Bay would be down in this area here. But you can see this algae bloom that's occurring here is another type of toxic blue-green algae called Anabina. And this formed in 2008 when we weren't getting enough fresh water. So some of the issues that we have when we don't get enough fresh water, we see these blooms occur, but we also see the salinity within the estuary climb to a point at which it starts to kill off some of our seagrasses or this predominantly freshwater tape grass called Valsinaria americana. And it also has impacts on oysters, and I'll talk a little bit more about that. So what's needed to get the water right? Well, during the dry season, we need a certain amount of flow, and during the wet season, we want to reduce those flows below a certain level, and I'll show you some of those thresholds. This is what happens when we see too much flow. Again, these are the nutrient impacts, and this is all related to not having enough storage throughout the system. So when you make these connections, these dredge connections between different parts of the system, from the Kissimmee, from Lake Okeechobee to the Caloosahatchee to St. Lucie, you get the water to the coast really quickly, and it's very flashy, so it gets there untreated. And when it gets there untreated, you have biological responses, and those biological responses are algae blooms in our case. And those biological responses can carry on to contributions to red tide. While red tide is not directly caused, and I'll use the word caused, by nutrient runoff from the landscape, it is fed or fueled by them, and that's been quantified in a lot of scientific research and journals, peer-reviewed and other documents. So we know that what we're doing on the landscape isn't helping the red tide situation. While it does start offshore, it moves onshore, it is fed by what we do on our own landscape. But again, my focus today is really on too little water. And this is an image that was taken in 2010. It shows a fairly healthy Valsinaria americana, which is tape grass or wild celery. That's a freshwater grass within the upper portion of the Caloosahatchee River. When we're talking about the upper portion, we're predominantly talking about this area from the Franklin Lock and Dam all the way down to about the Cape Coral Bridge. Historically, this tape grass existed between the US 41 bridges down to about the Cape Coral bridges. That was about 2,000 acres of tape grass habitat that previously existed prior to some of the mismanagement, we'll say, of the Caloosahatchee occurred beginning in 1999. And what's important about this is that it's not just the tape grass we're worried about. It's all of the other ecosystem components that tape grass supports. Whether it's the fish that you go out here and catch throughout the estuary or out in our marine waters, which spawn in those important low salinity zones throughout the Caloosahatchee or Estero Bay. I did my graduate work in Estero Bay and looked at the influence of freshwater inflow to Estero Bay. And we found that if you don't get enough freshwater inflow to those systems, that can impact the whole trophic food web throughout all of Estero Bay. That also happens in the Caloosahatchee. And so what happens is when you don't get enough salinity, we start to see this loss. This is the same grass bed that was taken later in December of 2010. You can see it's covered with algae. We got shoots that are about that tall versus, shoots here that are, 8 or 10 inches. But historically, I'll show you some photos of what it looked like historically. Prior to 1999, it was a very different habitat. But this low salinity zone, which we define by an area within the estuary that's somewhere between 0.6 practical salinity units and 5 practical salinity units. When you look at the whole continuum of an estuary, it goes from 0 all the way to pure seawater at 35. So just to give you an idea of what scale we're looking at. This is the upper estuary. We're looking at those low salinity zones. And those low salinity zones support fish, shrimp, blue crabs, a lot of our economically and ecologically important finfish and shellfish. So just so you all know how that relates. And so, let me go back. So what the minimum flow and level, at least based on a lot of science that we've collected, along with the Sanibel Captiva Conservation Foundation's Marine Lab and others, it suggests that the minimum flow and level should be somewhere between 650 and 720 cubic feet per second.
Can we dim the lights so we get a better?
Is this the switch here?
Yeah.
Okay, is that too much?
No, it's
Okay, very good.
all right.
Is that okay? Okay, very good. And so some ecological targets have been established for the Caloosahatchee, and we have low flow targets and we have high flow targets. I'm going to focus on the low flow targets today. But these were targets that were established by the South Florida Water Management District scientists. And there's some very, very good scientists that work for the South Florida Water Management District. And this goes back to the early to mid 90s when they started developing targets for the Caloosahatchee. And what we found is the low flow targets, somewhere around 450 cubic feet per second, at least going back to the late 1990s, was protective of the ecosystem in the upper estuary. If we get above flows of 2,800 cubic feet per second on the high flow end, that's when we start to see impacts to the lower estuary. That's somewhere around Shell Point, if you're familiar with that area. And when we start to see flows above 4,500, we see impacts in San Carlos Bay. It starts to impact our marine seagrasses. That means the salinity is actually getting too low, and we're starting to impact the marine seagrasses. And when we start to get above 6,500 cubic feet per second, which we did for quite some time this summer and in previous years, that starts to impact the Gulf of Mexico, and that's where you guys really start to see some impacts in your coastal waters. From Fort Myers Beach all the way down to Bonita, Estero area, we start to see those impacts to offshore waters and that dark freshwater plume that extends well out into the Gulf of Mexico. Again, we're focused on this upper estuary here for the low flows. And again, these targets, this shows you kind of where the targets impact the certain regions of the system. So at 650 cubic feet per second or less, we're impacting the upper estuary. At flows greater than 2,800 cubic feet per second, we're impacting the lower estuary. At targets or flows above 4,500, we're impacting San Carlos Bay up into Matlacha and Pine Island Sound. And then it flows over 6,500, it extends well out into the Gulf of Mexico. This just shows you some of the ecological organisms that we're trying to protect with these targets. Again, we focus on the Valsinaria americana, the freshwater tapegrass, for these low flow issues. So going back in history here, historically, these are some photos that were taken in 1979 to 1984, taken by John Cassani, the Caloosahatchee River Keeper. And these, it's kind of hard to see in these images, but all of this green area here is tape grass. You could essentially walk across it. The blades were over 1 meter long, over 3 feet long. And in 1999 was the last time we saw habitat where we saw blades that exceeded 1 meter long, and those plants were actually flowering and being productive and providing productive habitat. But that was a pretty significant habitat and covered about 2,000 acres in the Caloosahatchee. There's a good example of what it looked like. You can imagine all the fish, the manatees, and all the other organisms that were supported. Not to mention, as the water moves through that system very slowly, it has a cleansing effect. It's almost like a filter marsh. The nutrients are being taken up by the grasses. The water is being purified before it gets to the lower estuary and out into the San Carlos Bay and into the Gulf of Mexico. It had a tremendous baffling effect on those nutrients and sediments that move through that system. And so this gives you an idea. This was a graph that shows from 2007 through 2009 when the flows were within the preferred range for this Valsinaria americana, this tape grass. And you could see only a brief period of time between July, July and, October of 2009, we were in the optimal range. And most of the time we're outside the box. And that's the problem, is that we're not providing enough flow to keep the salinity below what's needed to maintain that grass. And so what is a minimum flow and level? A minimum flow and level is the limit at which further withdrawals would be significantly harmful to the water resources or ecology of the area, and that's in Florida statutes. And the South Florida Water Management District defines significant harm as the temporary loss of water resource functions which result from a change in surface or groundwater hydrology that takes more than 2 years to recover, but which is considered less severe than serious harm. Well, we would argue that the impact of the tape grass in the upper estuary, which has been identified as what's called a valued ecosystem component for the estuary, is now on the order of serious harm, because not only has it, we haven't recovered it in the past 2 years since the rule was adopted in 2001. We're now proposing a rule, or the district is proposing a rule, that shifts the baseline away from protection of that resource because they haven't been able to recover it, because they haven't been able to get the salinity at the appropriate levels in the past 18 years. And so now they just want to shift the baseline. And that's our main concern about this change in the rule. And so why are we challenging the proposed rule? Well, we feel that the proposed rule is less protective than the 2001 rule. And it's a flow target versus a salinity target, and I'll go through why. And that it shifts the ecological baseline away from a sensitive ecological indicator habitat like tape grass, which is a habitat, not a single species, which they would argue is single species management, but we would argue it's representative, an ecological indicator of an entire ecosystem. And their methods average the salinity targets or the flow targets over 11 different components rather than the most sensitive ecological indicators, which is tape grass. And this would result in higher dry season salinities and impacts to all organisms that depend on the low salinity zone. And I, again, talked about the fish, the invertebrates, and that's the area that we're trying to protect. And the proposed changes compared to the 2001 rule that's in place now, the magnitude change in flow would be from 300 to 400. And you're probably asking, well, that's an increase, not a decrease. That's correct, except for we're shifting the duration focus away from the salinity target of 10 practical salinity units or parts per thousand, which is the same, to a 30-day moving average of 400 CFS flow. While they've added this 10 PSU as a secondary, notice this and here, they would have to exceed the 400 CFS cubic feet per second target for more than 30-day moving average and have 10 PSU violated. We know already that 400 does not produce 10 PSU, practical salinity units, at Fort Myers at the measuring station. So it is one of our major arguments, is that you don't get 10 practical salinity units with 400 cubic feet per second. And then, of course, this return frequency, an exceedance under the 2001 rule occurs when you have it for two consecutive years. And just so you all know, over 11 out of the last 18 years, we've had violations of the existing rule. However, what we call the prevention and recovery strategy, that is the C43 West Basin Reservoir. That's a reservoir that's going to store a large amount of water within the Caloosahatchee. It was about a $600 million project. Now they're estimating it's about $1 billion project. That's supposed to be completed by 2022, and they do not even need to meet this rule until that prevention and recovery strategy is in place. So our other argument is that what's the hurry in updating this rule with bad information when we can't even enforce it until 2022? So that's another one of our arguments. And I'm not going to get into legal strategy because we are in the middle of litigation here, so I have to be careful on how we talk about strategy and things like that. But the component analysis, the study that they did, averages it over 11 different organisms or 11 different component studies. And it doesn't weight it on the most sensitive one, which is the Valsenaria tapegrass, and it's based on measured data, not just modeled data. And we're arguing also that some of their modeled data there are some errors in the way they've modeled this data. And we'll, of course, have expert witnesses that will speak to that at the hearing. The hearing is scheduled right now for October 29th and 30th. It's a very accelerated process. It's a 30-day timeline from the time we file the petition to challenge the rule to the time we actually have to appear in front of a judge, an administrative law judge. And so I think I only have one or two more slides here. But the final Caloosahatchee River West Basin Storage Reservoir Project Implementation Report and Environmental Impact Study that was produced in November 2010 outlined some of the ecological performance measures. And what it cited for Valsenaria was that the optimal target for the tapegrass was 800 to 1500 CFS. They're arguing that 400 CFS is protective of tapegrass. We're arguing that it's not, and I think we have some really good science to suggest that. Here's some data that was collected in 2017 by the SECF Marine Lab that shows you that when we were getting flows between December of 2016 and May of 2017, we were getting flows of 630 cubic feet per second, and our salinities were at 11.6 PSU. Again, here, when we got flows of about 730, that put us at 9.6. And when we had flows of 360, salinity shot back up to 15.3. Same thing happened in 2018. This year, from January all the way to May, we were getting flows above 650 cubic feet per second. Our salinities were above 10. And here we were getting flows of 700 and salinities were at 12. That's pretty clear that the targets that they're proposing are not going to work for the estuary. And so this shows you some of the habitat that would be lost if we get 400 CFS for the next several years, that will probably lose another 600 acres of tapegrass. And the tapegrass that we have right now, I would argue, is not biologically productive. We're talking about shoots that are a couple inches tall versus back in 99, prior to 1999, where it was over a meter, which provided really good habitat. That's what the habitat looked like. And again, that baffling effect provided really good water quality for the estuary and our coastal waters, and that's what's been lost, and we want to recover that. And of course, the one thing I didn't talk about is that if we get the water we need during the dry season, that means there's less water in Lake Okeechobee. While we were getting above the minimum flow this year, we were getting over 650, and the minimum flow would be 400. We were able to get that water out of the lake. We were actually asking for between 800 and 1,000 cubic feet per second from January all the way to May. That would have been several inches of water out of the lake that we wouldn't have had to receive, and the East Coast wouldn't have had to receive this summer. So we think it's a win-win. Unfortunately, we're competing with water supply for that same water, and I think that's the big argument and why the South Fork Water Management District is challenging us, is arguing against our challenge. So thanks for your time. If you have any questions.
Hit the light.
Yep,
if you would,
absolutely.
Thank you for your
Absolutely.
extensive presentation.
Sure.
After October 29th and 30th, then you've got a hearing examiner decision, right? What happens after that?
So the administrative law judge is either going to determine, in the favor of the district that they have sound science, which has been peer reviewed, but it was peer reviewed in a vacuum somewhat. They gave them specific things to look at and didn't provide them all of the information, in my opinion. And so once that's all reviewed and the administrative law judge determines whether that the update can move forward, then at that point we'll just have to deal with what we have. The politics could change after this next election. I think both of the gubernatorial candidates have talked about the need for changing the makeup of the Water Management District Board, so that may be helpful. But our focus really is on the science. And so if they rule in favor of us, then we would argue that what we have in place today is more protective because it's based on a salinity target, not a flow target. We would want the Water Management District to move forward with a couple-year pilot study between now and when the C43 reservoir comes online to use measured data, not modeled data. And that's what they should have been relying on for this whole rule to begin with. But again, it's all about competing water uses, and I would argue that the water has been over allocated throughout the system, and there's not enough water to give us what we need and also meet the legal obligations of the permitted users. So that's where the rub is. Otherwise, there wouldn't be such a pushback on this issue.
Well, thank you. We don't have time, Joe, sorry.
And I can give you my card if you guys want to talk to me afterwards. I can leave a couple cards with Don.
We just, the village moved affirmatively to join the coalition cities in support of this. And we just wanted to be sure that everybody here understood the issues so that as it proceeds over the next years, that we can have some effective input at that time. Thank you, James.
Thank you.
For coming and